So hello friends, today we have microservices design patterns, some commonly asked questions as per all the interview experiences. So let's start. First of all, we'll be considering one use case where we have an onboarding module, just like to onboard the customers, and the application is customer facing. So let's start with a single DB design pattern that is also known as an anti pattern because that is not encouraged much as per the industry standards and for the various other security reasons as well. So ideally, it is a good use case when we have just the two microservices and one common database. So as you can see, the pros are that it is very simple implementation. It supports synchronous communication, but definitely it is not a scalable model. Optimization will be a challenge. Frequent deadlocks and timeouts will be there. Now to overcome this, we have two-phase commit design. What it does is we instead of interacting with the DB and persisting the data directly, we do the transactions into two parts. We prepare the queries, then based on the readiness of the queries, we commit the queries. So that way it gives an wrapper illusion that we have a transactional, just like a transactional annotation we have in Spring. Here also we have a transactional wrapper that, and it also honors the ACID principle that the database operations will be done in a single go. That means there won't be any dirty read or dirty write, as we say. So the data will be persisted all together, or it won't be persisted at all, and that and it also provides the flexibility of rollback as well, because in case our first query is ready and the second query is not ready, or we do encounter some error, then we can simply roll back without committing. So yeah, this is the advantage of this two-phase commit design. Now coming to the cons, if the interviewer asks you why it is discouraged, then you can say that it is having a blocking nature, and this might lead to a single point of failure, because if one query is failing, the other queries are working fine, then again we are not going ahead with the query persist. So definitely it will have this scalability issues as well, because we need to make sure that same replicas have to be prepared every time, and the data has to be consistent across the database instances. Now coming to the next pattern, there is API composition design pattern. As the name suggests, that it will have a proper aggregation of the API responses. That's why it is known as a composition design. So in this example, we are having user details and onboarding as two different services. They are dedicated databases which are actually syncing in the background. Because if we use any background database sync up technology like CDC methodology, in that case, you can assume that that won't be taking much of the time in terms of the data sync up. So now coming to the aggregation service, what it does is it waits for the responses from both the services, two or more services rather, and once the response is handy, then only it prepares the final JSON or XML based on the response type, and then it shares the response as a holistic API response. Now coming to the cons for this, again as you can see, it is leading to a single point of failure because we are relying heavily on the aggregator service. And also, even if you create multiple replicas, or if you replicate this aggregation services as many services and add a load balancer on top of it, then again you have to make sure that the user details and onboarding data is aggregated properly among them. In case anything fails in that aggregation activity, then there is no response sent by the user detail or onboarding separately, because we have to send the holistic response. Yeah, thanks for your time. So this was the part one. We will be covering more in the subsequent videos, so stay tuned. Thank you.